Alright guys, so here is a problem of using superposition. Basically what I've done is I've drawn a free body diagram here of a shaft. I don't know if you can see these. It's negative 353 pounds right here, 680 pounds right here, 502 pounds right there, and 175 pounds right there, with a spacing of 15 inches, 21 inches, and 12 inches. And what I have to do is find the deflection of this system. Normally, this problem is given to you and you don't know all these forces and reactions and you have to find those, but that's basic statics, so we're just skipping right to the deflection part. The way we're going to solve this is by using superposition. And basically, with superposition, what you're going to do is you're going to redraw this free body diagram with just one or two of the forces actually acting on it. And you're going to compare to the tables in the back of your book. I use the Shigley Machine Design book, so it's in Appendix 9. You have the different superposition situations you have. So I'm just going to go ahead and use that. So we have, we're going to look at it with the force right there and the two reactions. So you have a bending upward just like that. And then we're going to look at it here again in a different version with the second force B right here. So I'm supposed to find the deflection at A and the deflection at B. So starting with the deflection of A, if you go back into the Shigley design book, you will see this picture. So this is obviously the one you want to use. We just set it up like this. I actually found this and then drew this free body diagram in order to set it up to look like this. So in order to find the deflection at B, we're going to go ahead and use the equation, this equation right here from y a to b. So I'm going to go ahead and write that down. We're going to make it negative fbx all over 6 il of x squared plus b squared minus l squared. Okay. Now you'll notice that I put a negative in front of mine from the actual equation that's used here. The reason I did that is because the force that I found is opposite to the force that's shown in this picture. So you have to compensate by that by reversing the equation. Other than that, x is the distance. X is equal to 12, which is this distance up here. B is equal to 36, yes, 36, which is the distance from here to there. And then L is the total distance, which is equal to 48 inches. This is all in inches. Now, you also find E. You calculate I based on the area that you're given. And if you do all of that, if you calculate I is going to be equal to, well, in this case, it's going to be 0.2485, where I is equal to pi d to the 4th over 64. So that's a basic equation, a little side calculation that you can do there in order to calculate this. And then E you find in Appendix A5 of the Shigley book. And then you sub all these values in, and if you calculate that, you'll end up with the deflection at A, we'll call it ZA, is equal to 0.1182 inches. Okay, so that's pretty easy. The first force is the easiest one. The second one is where it gets a little bit tricky, because if you want the deflection at A and B, you know that while A is pulling up this way, B is pulling down this way, so how do they compensate for each other? Well, we're basically going to ignore that right now, because since we're just looking for the deflection at B, the way you ignore A, since all this is A up here, we calculated A's deflection, we know how far A itself is going to go, but now to find how B itself would go. Normally you would think, well, just use the same equation and imagine that B is moved over here now, and change the ratio of B and 9, so on and so forth. But you can't do that, because if you use the exact same equation you used for A, you'll be going this direction, which means you'll be including the A force, or not excluding the A force, which you have to do in order to find the deflection of B just as it is. So we're actually going to take the equation coming from this direction, which is this equation right here, that one right there. And again, well, B is in the actual direction, so we don't have to change the signs at all of this equation. So just going ahead and writing that out, we've got excuse me, negative negative FA of L minus X over 6E I L X squared plus A squared minus 2L X. Okay, so yeah, as you can see, it's a little bit different. So we have the total distance, and then the x is the distance from here to there. If you look at this equation, you'll see that this is the deflection for BC. If you look up here, BC is the deflection of this half. So even though the values are measured this direction, the actual deflection is just on this side. So if you're confused by that, just a little clarification there for you, because I told you we're excluding A, so we're just taking this half of the bar that's being acted on by B, which gives us this equation. And even though it looks like it's working over with the values over here, we can actually just ignore that because it's taking this half the bar. I hope that made sense. Alrighty. Okay, so moving on like that, we are going to have all the values are going to come together, and if you calculate that, you'll get A is equal to 12 inches, X is equal to 33 inches, and then let's see here, calculating that all out with the same I and E that we used in the last problem, we get ZB is equal to 1.1103. That's incorrect. But in showing this to you, I was using a solution. There's actually an error in that, because this B is going in the correct direction. You need to just use this equation as it is, as it's shown right here, because it's coinciding with all of this. You actually add a plus to that, which means that the ZB deflection will be negative, which makes sense because, okay, we have ZA as a positive deflection. If we choose this as Y, or as Z, then that direction will be positive. So we'll have a positive deflection in that way. And down here we'll have a ZB, which is a negative deflection. So a negative deflection down that way. So that actually turned out the way we wanted to. A little snafu right there, so watch out for that. Just make sure your lines are all straight. But yes, we have now have the deflection at B and deflection at C.